Welcome to another lab session. In this exercise, we'll be looking at transient response of thermal sensors. The two types of sensors we'll be evaluating the performance on are thermocouples and thermistors. The equipment that we'll be using in the experiment is a digital thermometer, a hot bath, a resistor box, or intranet data acquisition system, along with our computer and software. We'll also be using a thermistor as one of our sensors and our thermocouples, J and K. We will be observing the transient response on the J and K thermocouple, J being the white and K being the yellow. We'll also be observing the transient response on the thermistor. This will be done by submerging these sensors into the hot bath, then recording the temperature across each sensor while removing them from the hot bath. We'll be observing the thermocouple and thermistor separately because they require different circuits. Let's begin with the thermocouple. Both J and K thermocouples are connected to the intranet data acquisition system in differential voltage, meaning negative and positive, opposed to grounds and positive. Each thermocouple will be assigned a channel. Let's have a look at our hot bath and thermocouple connections. This is our setup with our hot bath, thermocouple, and digital thermometer. Once the temperature gets to 100 degrees, we would start the experiment. And as you can notice, our thermocouples, both J and K, are extended and submerged into the water. This is what a typical thermocouple looks like. At this end, we have two different type wires connected, which is our measuring junction. And these two free ends are connected to our data acquisition system, negative and positive. We would verify the temperature of our hot bath by using a thermometer. Then we would place both our J and K thermocouple into the hot bath, allowing the temperature to stabilize. Once the digital thermometer gets to 100 degrees, we can start the experiment. When all sensors are reading approximately the same values, we would then rapidly remove the sensors from the hot bath and observe their transient response for approximately 2 minutes. So now let's observe the transient response for J and K thermocouples. The screen you're looking at is our intranet data acquisition system software. The top graph represents our J thermocouple. The lower graph represents our K thermocouple. At this point, we're roughly at 100 degrees. So what we would do is to hit start, remove the thermocouple from the hot bath, and observe the transient response over 2 minutes. Now that we're roughly at 100 degrees, we would hit start, and when we get to 5 seconds, we would remove the thermocouple from the hot bath and observe the transient response on the graph over a period of 2 minutes. And as you can observe, the temperature is decreasing. There's a nice curve forming here. So we would just observe this response over the time of 2 minutes. And the software is configured to stop recording after 2 minutes. So let's sit this through. So now the recording is complete and we would save this data. Stop, save. Next, we'll observe the transient response on the thermistor. This is a typical thermistor. The free end would be connected to our intranet data acquisition system, just as in the thermocouples, and this is our measuring end. Our thermistor is already inserted into the boiling water, so at this point we can begin the experiment. Let's have a closer look at our thermistor connection to the intranet acquisition system. The thermistor is a variable resistor, so it requires a circuit such as a Wheatstone bridge or any device that can monitor variable resistor. In this exercise, we'll be using a voltage divider circuit. As seen on the figure, the unknown would represent our thermistor, and the shunt represents our resistor box. For this thermistor, the shunt value needed is 1,000 ohms. And this would be our resistor box. This diagram depicts the voltage divider circuit used by the intranet to monitor the thermistor's temperature. V out represents the excitation volt for the voltage divider circuit, and the differential volt, V negative and V positive, is the voltage across the thermistor, which the software converts to temperature. Now let's run the experiment for the thermistor. Now that our temperature is at 100 degrees, we can start. Once we get to 10 seconds, we would remove the thermistor from the hot bath, and we would then observe the transient response over a period of 4 minutes. And as you can observe, the temperature is decreasing, and we're getting a very gentle graph going down. And we'll observe this response over the 4-minute period. The software is configured to stop recording after 4 minutes. So we'll just observe this during this time. So we're just about halfway, and we're getting a very smooth graph going down. So we're maintaining a nice steady graph. We're just about approaching 3 minutes. So now that we're at the 4-minute mark, the software has stopped recording, so we'll just go ahead and save. At this point, we have obtained data for J and K thermocouple along with the thermistor. All data recorded will be supplied to you by your professor. Thank you.